Hi and welcome to the first part of a video series on LINQ. This video is also the first part of the 7th tutorial in an advanced C# course. Later in this tutorial, we'll look at a code example to help with our understanding of LINQ. But let's first answer the question, what is LINQ? LINQ stands for Language Integrated Query. LINQ is defined in the Microsoft Docs as the name for a set of technologies based on the integration of query capabilities directly into the C# language. LINQ was originally released as a major part of .NET Framework 3.5 in 2007. Please consider subscribing for more content on advanced C# concepts and much more. And please ring the bell so that you'll be notified of future content released from this channel. Here is a paragraph from the Microsoft Docs, which provides an excellent overview of what LINQ is. Language Integrated Query, LINQ, is the name for a set of technologies based on the integration of query capabilities directly into the C# language. Traditionally, queries against data are expressed as simple strings without type checking at compile time or IntelliSense support. Furthermore, you have to learn a different query language for each type of data source: SQL databases, XML documents, various web services, and so on. With LINQ, a query is a first-class language construct, just like classes, methods, events. You write queries against strongly typed collections of objects by using language keywords and familiar operators. The LINQ family of technologies provides a consistent query experience for objects, LINQ to objects, relational databases linked to SQL, and XML, LINQ to XML. Note that you can write LINQ queries in C# for SQL Server databases, XML documents, ADO.NET datasets, and any collection of objects that support the IEnumerable interface or the generic IEnumerable interface. So, for example, you can perform LINQ queries against collection types like an array, generic list, generic dictionary, generic queue, generic stack, etc. Basically, any collection type that implements the IEnumerable interface or the generic IEnumerable interface. LINQ support is also provided by third parties for many web services and other database implementations. You can create custom providers using IQueryable. Custom providers will not be discussed in detail in this video series. If you would like to learn more about implementing your own custom provider, please navigate to this URL. In this video series, we'll primarily focus on LINQ to objects and LINQ to entities. LINQ to entities provides language integrated query, LINQ, support that enables developers to write queries against the entity framework conceptual model using either Visual Basic or Visual C#. So, Entity Framework Core is a modern object database mapper for .NET. It supports LINQ queries, change tracking, updates, and schema migrations. Entity Framework Core, or EF Core, can be used to work with many databases, including SQL databases, on-premises and Azure, SQLite, MySQL, Postgres, and Azure Cosmos DB. In this video series, we won't look at LINQ to Dataset or LINQ to XML. Please navigate to this URL for more information on LINQ to Dataset, and please navigate to this URL for more information on LINQ to XML. As always, all links mentioned in the videos created by this channel are available below in the description. To get started with LINQ, in this video we'll focus on LINQ to objects so that we can first get a basic idea of what the implementation of LINQ looks like in code and how it can be used for querying C# collections. Before we create a code example, I want to mention that in the C# courses created for this channel, both the beginner's course and the advanced course, there's a push towards cross-platform development. This is without a doubt the future of development. the .NET Core runtime enables cross-platform development and cross-platform deployment for .NET developers. The .NET 5 runtime, the official release is expected in November 2020, will further eliminate barriers to cross-platform development for .NET developers. If you haven't seen the second part of this advanced course, please do so to gain a basic understanding of .NET 5. So in the spirit of cross-platform development, I've decided to demonstrate this code example on my Mac platform using Visual Studio 2019 for Mac Community Edition. If you have a Mac platform and wish to follow along on your Mac and you don't yet have Visual Studio installed, you are able to download and install Visual Studio Community Edition 2019 free of charge from this location. All links mentioned in this video are available below in the description. If you are using a Windows OS, please don't let the fact that I'm using a Mac platform put you off following along with this tutorial. In terms of the code example that we'll create in this video, the coding experience using Visual Studio for Mac is almost exactly the same as the coding experience using Visual Studio for Windows, so this should not be a barrier for a learner to follow along with this demonstration. If you haven't yet installed Visual Studio 2019 on your Windows platform, please view a video created by this channel which provides a guide to installing Visual Studio 2019 Community Edition free of charge. So firstly, let's create a .NET Core console application. Let's name this project the Pretend Company application. Before we write calling client code in the main method, we are going to add two standard library projects. Let's first add a standard library project named TCP Data. Let's then add another standard library project named TCP Extensions. So let's now go to our project that we named TCP Data. Let's delete the class that has been automatically generated for the TCP Data project. Let's add a new class named Employee. Let's add 6 auto-implemented properties to the Employee class. ID as int, first name as string, last name as string, annual salary as decimal, isManager as boolean, and lastly, department ID as int. Let's add another class to the TCP Data project. Let's name this class Department. Let's add 3 auto-implemented properties to our Department class. ID as int, short name as string, and long name as string. Let's add a class named Data to our TCP Data project. Let's make this class a static class. So let's add 2 public static methods to the Data class. Let's first create a static method named getEmployees, which returns a generic list strongly typed as employee. Let's ensure that we include the appropriate using directive for the use of generic list objects at the top of our code editor. So let's include a using directive to the system.collections.generic namespace, like this. Let's write the code to add some made-up employee records to a generic list that is strongly typed with the user-defined type employee. Let's write code to return the list of employee records to the calling client code. Let's add another static method, and let's name this method getDepartments. This method also returns a generic list object, but this generic list object is strongly typed as department. Let's write the code to add some made-up department records to a generic list that is strongly typed with the user-defined type department. Let's write code to return the list of department records to the calling client code. So as you can see, the getEmployees method returns a list of employee records, and the getDepartments method returns a list of department records. So in order to gain an understanding for how LINQ works, let's ensure that we properly understand two fundamental concepts, i.e. the concept of extension methods and the concept of lambda expressions. So let's go to our TCP extensions project. Let's delete the class that was auto-generated by Visual Studio when we created the project. Let's add a class named extension. So in order for our extension method to work, we must make the extension class a static class. So we are going to add a method named filter. The idea here is we want a way where we can extend the functionality of any generic list that is strongly typed with any C# data type, including user-defined types. We can achieve this by creating our own extension method. So for example, if we want to filter employee records by criteria that we are able to specify through a lambda expression on a generic list that is strongly typed as employee, we can do this through our filter extension method. This will be demonstrated in the calling client code in a bit. So how do we create our own custom extension method? So I'll first create the method signature for the filter extension method. First, notice that our method, like the class in which it resides, must be static, which is achieved by including the static keyword in the relevant extension method's method signature. So if we look at the first parameter in the filter method's method signature, we can see that we are using the this keyword preceding the data type of the first parameter, which is a generic list of type T. The this keyword in this context indicates to the compiler that the relevant method can be called on an object of the data type of the relevant parameter. In this example, that is a generic list which contains a type T placeholder. As we know from the video series on C# generics, a developer is able to pass a data type argument to the parameter of type T, which can be any C# data type, including user-defined types. The data type specified will be chosen depending on the requirement that needs to be met by the calling client code. We'll demonstrate the consumption of client-side code for the filter extension method in a bit. So let's look at the second parameter, which is of the delegate type Func. For more information about the Func delegate type, please view a video created by this channel on this topic. A link to this video is available below in the description. The first data type parameter passed to the Func delegate type represents the first data type of the first parameter of the method referenced by the relevant argument passed into this parameter. The last parameter in the Func delegate type definition is the return type of the method referenced by the argument passed into this parameter. So the first parameter passed into the Func delegate is of type T, and the second parameter is of type bool. Note that a predicate delegate type can be used to define method definitions for a method that returns a Boolean value. So we could replace the func delegate type with a predicate delegate type. Let's use the func delegate type, but please note that we could also achieve the same end using the predicate delegate type. And as you can see, this method will return a list of objects of type T to the calling client code. So let's complete the logic for this method. Let's implement the code for the filter method. So basically, we are looping through the list on which the filter extension method is invoked. We are then adding its elements to a new generic list, also of type T. Whether or not we add this list item is based on the Boolean value returned by a method reference passed into the second parameter of the filter method. So the relevant method reference is stored in the argument passed to the parameter named func. As you can see, the method that the variable named func references accepts an argument of type T. So we are passing in each item stored in the calling client's list, which is the generic list on which calling client code will invoke the filter extension method. If the method that the func variable references returns true, the item stored in the iterated list is added to a new list. We then return the new list containing the filtered items to the calling client code. So this effectively means that the calling client code is able to use our filter method to filter any generic list based on a method created in the calling client code. This method created in the calling client code will contain the logic for filtering the relevant generic list. A reference to this method will be passed into the second parameter of our filter extension method and must adhere to the method definition represented in the second parameter of the filter method, i.e. the definition represented in the func delegate type. So we are now going to implement the calling client code, and you'll see that the method passed into the second parameter of our filter method will be an anonymous method, i.e. a method that is not named. This method will be expressed as a lambda expression. We'll now see how we are able to filter a generic list using our filter extension method through calling client code in the main method of our application. Right, so let's go to the .NET Core Console project and write the calling client code in our main method. Firstly, let's reference our two standard library projects from our .NET Core Console project. So let's right-click the Dependencies node in the .NET Core Console project and tick TCP data as well as TCP extensions. So let's test our filter extension method. In a bit, I'll further elucidate why it is important to understand extension methods and lambda expressions with regards to LINQ. Through the magic of how extension methods work in C#, we should be able to call the extension method on any generic list object. So let's define a generic list that is strongly typed as the employee user-defined type. So we have a red squiggly line under our generic list type definition. So to fix this, we need to include a directive at the top of our code to the system.collections.generic namespace. We can see that there is a red squiggly line under the code that strongly types our generic list as the user-defined type employee. So to fix this, let's include a directive at the top of our code to the TCP data namespace. Great! So through the magic of extension methods, we should see the filter method appear in the IntelliSense drop-down list when we add a dot after the employee list variable. Okay, so why are we not seeing the filter method appearing in our IntelliSense drop-down list? The reason for this is because we haven't included a using directive to the appropriate namespace. So let's include a using directive at the top of our code to the appropriate namespace, i.e. TCP extensions. So now if we add a dot immediately after the employee list variable, the magic of extension methods is revealed to us, and we can see our filter method in the IntelliSense drop-down list. So note that when we open brackets to pass in appropriate arguments to the filter method, we see that only one parameter is required. This parameter was the second parameter we defined for this method. So why is the first parameter in the filter method not listed when we open the brackets in this way? Well, the answer to that question is this is how extension methods work. The consumer of the code, i.e. the calling client code, does not need to pass in the first parameter. This is automatically handled behind the scenes, as it were. By default, the first parameter is the object on which the relevant extension method is invoked. So in this case, the list of employees stored in the employee list variable is passed into the filter method into this parameter automatically. So if we look at the filter extension method, we can see that this keyword precedes the definition of the first parameter. The this keyword in this context is telling the C# compiler that the argument passed into this parameter is the object on which the relevant extension method is invoked. So we have access to the argument passed into the first parameter automatically. Okay, so the second parameter accepts a delegate object that points to a method that needs to be created on the calling client. So this method that we'll create essentially tells the filter method how we want our list filtered. So we are able to define this method in the calling client code through the use of a lambda expression. A lambda expression is a concise way to represent an anonymous method. If we look at the definition of the relevant delegate parameter, we need to define a method that accepts an argument of type T and returns a Boolean value. So the C# compiler has enough information to infer that the intended type for type T is employee in this context. We are calling the filter extension method on a strongly typed generic list. The generic list is strongly typed with the employee user-defined type. So say we want to filter our employee list based on the value of each relevant employee item's isManager property. We want to filter the list where we only want to return those employee records where isManager is true. So we want to return all the records from our list where the relevant employees are managers. So to achieve this, we can pass in this lambda expression. Here we are telling the filter method how we want our list filtered. Let's write code to print the results to the console screen. Right, let's run the code. Okay, so we have no data. We of course need to populate our employee list with data. So let's assign the value returned from data.getEmployees to the employees list variable. Right, let's run the code. Great, and you can see that only the employee records where the relevant isManager property value is set to true are returned to the calling client code. Great. And we can of course inject the converse of this logic into our filter method through the relevant lambda expression like this. So we are now saying we only want to bring back employees who are not managers. Let's run the code. Great. And for good measure, let's modify our lambda expression so that the filter method only returns employees that earn less than $50,000 a year. Great. And because we have used generics for our filter method, we can call the filter method on a list of various C# types, including user-defined types. So let's prove this and call our filter extension method on a list of departments. Let's filter the departments based on the department's short name. So let's bring back the finance department and the human resources department. Great! Let's bring back only those departments with IDs greater than 1. So the point of this is to show you the flexibility that the combination of extension methods and lambda expressions create when writing the calling client code. The combination of extension methods and lambda expressions not only provide this flexibility, but at the same time ensure that the calling client code is clean and concise. Once we understand how extension methods and lambda expressions work, they are incredibly powerful tools. So, how do extension methods and lambda expressions work in relation to the topic of this video, LINQ, Language Integrated Query? Extension methods and lambda expressions are fundamental to how LINQ is implemented in C#. The enumerable class and the queryable class are two static classes that contain extension methods. The enumerable class and the queryable class are both members of the system.link namespace. So to gain access to the extension methods provided through LINQ, we can simply include a using directive to the system.link namespace. Without including a using directive to the system.link namespace, you can see that we are not able to access the where extension method provided by LINQ to perform our filtering operation on a collection that implements the IEnumerable interface. So let's include the system.link namespace. We now have access to LINQ's where extension method, so we can now replace our custom filter extension method with the where LINQ extension method like this. We don't need to create our own filter extension methods to perform such queries on our data. LINQ has got us covered for this. LINQ also provides us with a SQL-like query syntax. So for example, if we wanted to produce a query result by joining selected fields from data selected from our collection of employee objects with selected fields, or field in this case, from data in our collection of department objects, we can use LINQ query syntax to perform our inner join operation on these two collections of data, like this. In the LINQ query, we want to include the department long name field so that we can have a descriptive name for our department in our results set rather than displaying a result that only contains the department ID, which is available in the employee type. So we can achieve this result by using the join clause in a LINQ query to perform our inner join on our collection of employee objects with our collection of department objects. We have the department ID property in the employee type, so we can join using this department ID property in the employee type to the ID property, which is a member of the department type. So say we were to write the equivalent query using Transact SQL against a SQL Server database that contained an employee table with the same data schema as our employee type, and a department table that contains the same schema as our department type. The transact SQL query syntax would look something like this. We are using an inner join to join data in an employee table with data in a department table. We are able to make the join because the employee table contains the department ID, which can be joined in our query to the ID of the department table. So you can see the similarities in syntax between the transact SQL syntax and the LINQ query syntax. The LINQ query is dealing with objects encapsulating the employee and department records. The employee list collection is like the employee table, and the department list is like the department table in this particular context. We have a select clause, a from clause, and a join clause in the syntax for both the LINQ query and the transact SQL query. However, the from clause in the LINQ query appears at the beginning of the query, and the select clause in the LINQ query appears at the end of the query. So there are differences in the ordering of the clauses when comparing the syntax of the transact SQL query with the syntax of the relevant LINQ query. An advantage of LINQ is it can be leveraged in our C# code to query data in a standardized way that is independent from the format of the underlying data source. The data source could be a MongoDB database, a SQLite database, a SQL Server database, etc. This will not affect the syntax of our LINQ queries. So the object layer provided by LINQ can be used for abstracting our queries of the data from the underlying data source. And by using LINQ, we also have the added advantage of compile time, strong typing, and the type checking provided by the C# compiler. Let me draw your attention to the select clause. We are able to return the data as an IEnumerable collection of anonymous types. We are assigning the collection returned by the LINQ query to a variable preceded by the var keyword. Beginning with C# version 3, variables that are declared at method scope can have an implicit type var. Through the use of the var keyword, the C# compiler is able to infer the types included in the collection returned from the query. So we are able to return a collection of objects that are of an anonymous type that we have defined directly within the LINQ query. Anonymous types provide a convenient way to encapsulate a set of read-only properties into a single object without having to explicitly define a type first. You can see how the use of anonymous types can provide the developer with flexibility and convenience when constructing relatively complex queries. Note that Microsoft recommends using the query syntax where possible as opposed to using relevant extension methods for the same purpose. This is because of the readability advantage provided in the relevant query syntax. There are, however, times where you'll need to use appropriate extension methods included within the LINQ namespace, because some functionality in LINQ does not have a query syntax counterpart. For example, if we wanted to calculate the average salary for all employees, we would need to use the average extension method like this. The same applies if we wish to query for the highest salary from a list of employee records. We would need to use the max extension method like this. This functionality cannot be performed through the use of query syntax. But where possible, query syntax is preferable due to the code readability advantage that this syntax provides. I hope you've enjoyed this video, which provides an introduction to LINQ. This video was created to help with the understanding of the fundamentals of LINQ, the advantages that LINQ provides, and how we are able to implement basic LINQ queries in code. LINQ provides us with an integration of query capabilities directly into the C# language. It is a very powerful technology that decouples query logic from relevant types of underlying data formats. LINQ provides a layer of abstraction that provides the developer with easy-to-implement syntax for querying collections of objects. The relevant collection types must implement the IQueryable or generic IQueryable interface or the IEnumerable or generic IEnumerable interface. Note that the IQueryable interface inherits from the IEnumerable interface, and the generic IQueryable interface inherits from both the IEnumerable interface and the generic IEnumerable interface. A suite of extension methods and query syntax are made available to C# developers, which provide flexibility when constructing powerful, readable queries against data encapsulated within appropriate C# collections. This video is a basic introduction to leveraging LINQ in the C# language. In the next tutorial, we'll delve deeper into this subject matter. Please consider subscribing for more content on advanced C# concepts and much more. And please ring the bell so that you'll be notified of future content released from this channel. If you feel you've gained value from viewing this video, please hit the like button. It will be greatly appreciated. Please feel free to share any of my videos with anyone you feel may benefit from their content. I'd like to thank those who have sent me such kind and thoughtful comments. I really enjoy reading your comments, so please feel free to share your thoughts with me in the comments section. The code created in this video is available on GitHub. A link to the relevant GitHub repository is available below in the description. Thank you and take care.